Hello everybody and welcome back. Today we are starting our first lesson of our stoichiometry unit. Now stoichiometry is a big word, but basically what we're going to find as we go through this unit is that it's a really big word that basically just means unit conversions. So if we think back to all the way back to our intro unit when you guys did the unit conversions from like meters to centimeters, millimeters, all that fun stuff, it's basically the similar process, but we're going to take it up a notch and we're going to apply it to now something called the mole, particles, etc. Okay, so today, before we get started with anything else, we have to first find out what is the mole and how do we do these unit conversions. So we're going to go ahead and get started today. So this was the video that was in your engagement assignment today, so hopefully you've already watched this. If not, go ahead and go back and do that right now because it does give us an intro to what we're talking about today. Alright, so basically what we're talking about today, the mole, it's a unit of measurement, okay? So it's a unit of measurement. And there are some common units of measurement that we can use to compare this to, okay? So for example here we have a carton of eggs, which is 12. And 12 eggs is 1 dozen. So 1 dozen is a unit of measurement. So if you have a dozen eggs, you have 12 eggs. But a dozen can also be used for anything else. So if you have a dozen donuts, that means you have 12 donuts. If you have a dozen cups of coffee, that means you've had 12 cups of coffee. So a dozen is just a unit of measurement. It tells us how many particles, substances, whatever it is you're talking about is in that unit. The mole is going to be the same way. It's just a unit of measurement. Okay? And for example here, 24 eggs would be 2 dozen, right? Because there's 12 in a dozen. 12 times 2 is 24. We can use some basic math to help us find out these units of measurement. Okay? So now let's talk about what the mole is. So the mole is notated by a lowercase n, and this is the amount of particles, aka moles. Okay, so if you see a lowercase n, that's going to let us know that we're dealing with moles. This is the number of particles in the container or in an element. Okay, so it'll just tell you how many particles are present. It can be particles, it can be atoms, it could be anything, because remember, a mole is just a unit of measurement. So in a standard amount, 1 mole is equal to 22.4 liters, that's the measurement of volume, or 1 mole is equal to 6.022 times 10 to the 23rd particles, and that is Avogadro's number. Okay, so this is going to be a number that you have to remember. Okay, so go ahead and commit it to memory. When you do these problems over and over, it'll become kind of second nature, so you'll remember it as you do the problems, but we do need to remember that 1 mole is equal to 6.022 times 10 to the 23rd particles. Now, what does that mean? That means if I told you, oh, I have 1 mole of eggs, that means I would have 6.022 times 10 to the 23rd eggs. Okay, so it's just a unit of measurement. So 1 dozen eggs is 12. 1 mole of eggs is 6.022 times 10 to the 23rd. Okay, it's just a number that we have to remember. It's a unit of measurement. So we can use moles as a way of counting the number of particles in elements and or compounds. Because remember, atoms are very small, right? They're so small we can't see them with the naked eye, and there's lots of them that take up space in your body, on the planet. And so when we're talking about them, because they're such large amounts, this helps us kind of condense it a little bit. If we talk about it in terms of moles, it'll help those numbers kind of be reduced, and it'll help us relate the particles to atoms, to elements, etc. Okay? So again, this number that we're going to keep in mind, 1 mole is equal to 6.022 times 10 to the 23rd particles. That is Avogadro's number. So remember, Avogadro was that scientist who had this theory that if you have the same amount of gases in a container at equal pressure, they would have the same amount of atoms or molecules. But again, he was kind of ahead of his time and people didn't believe him, so he died without his theory being realized. But now we do know that he was correct. So Avogadro, we honor him by labeling this as his number, but it's just the conversion factor, 1 mole, or measurement. 1 mole is equal to 6.022 times 10 to the 23rd particles. Okay? And again, this is scientific notation. So when we are putting this into our calculators, we want to make sure we're typing it correctly. And then, of course, when we do our practice problems, I'll show you guys how to do all that. So how big is a mole? So just to put it into perspective, 1 mole of marbles would cover the entire Earth, including the oceans, for a depth of 3 miles. That's a ton. And think about marbles. Marbles are not very big. So if you had a mole of marbles, it would cover the entire planet. So we're talking about large number of particles here. 1 mole of $100 bills stacked on top of one another would reach from the sun of Pluto and back 7.5 million times. Okay? I don't know about you guys, but I would love to have a mole of $100 bills. And again, that just means 1 mole. If you had 1 mole of $100 bills, you would have 6.022 times 10 to the 23rd $100 bills, because it's just a unit of measurement. Okay? So now here we get to the actual application. So we know the mole, right? We know how to relate it. 1 mole is equal to Avogadro's number, 6.022 times 10 to the 23rd particles. But we are going to do throughout this unit mole problems. So we're going to convert moles to particles, etc. Okay, today we're going to be taking a look at converting between particles and moles. Okay, the way we're going to do this is with dimensional analysis. This is the same thing that we did in our first unit when we did unit conversions. And remember, I told you you could do the skipping way with the King Henry died by drinking chocolate milk, but you guys had to do it also mathematically where you worked it out. And the reason we had to do it that way is because it's the same process here. So we're doing the same thing. So whenever you do dimensional analysis or you do a conversion problem, you can do a T-chart or you can do it with fractions. I'll probably be using fractions a lot in your examples just because I think it's easier for you guys to see. But this is how you would set it up. Okay, we always start with what we're given. And then you have to use a conversion factor to get to what you want. Okay, so you would set it up on the right-hand side. So we start on the left with what we're given, and then we start on the right-hand side with our conversion factor. For these problems today, for our intro, your conversion factor is going to be the mole. So what we'll put right here is 1 mole and 6.022 times 10 to the 23rd, depending on which way we're going. Okay, and I'll show you that in your assignment because I'm going to do some example problems with you. So 6.022 times 10 to the 23rd can be used to describe atoms, particles, or molecules. Because remember, it's just a unit of measurement. Like 1 dozen could be a dozen eggs, a dozen donuts, a dozen cups of coffee. A mole could be atoms, particles, molecules, whatever. Okay, again, it's just a unit of measurement. And we just have to make sure we keep this number in mind. 6.022 times 10 to the 23rd. Okay. So let's take a look at a practice problem here, and then of course I will do some more practice in your assignment for the day as well. So it says the average person produces 16 moles of water. How many particles of water does the average person produce? Okay, so here we're starting with 16 moles, and we want to know how many particles we're producing. So we're going to do a conversion here. So let's first write down the steps. Number 1, we're going to write what we're given. Number 2, we're going to determine what we're converting to. Number 3, we're going to set up the units so that they cancel properly. Then we're going to add our numbers based on our conversion factors. So in this case, it's Avogadro's number. Okay, so let's take a look at what that looks like. So step number 1, write what we're given. We have to go back to the problem. The average person produces 16 moles of water, and we want to know how many particles that of water is being produced. Well, we're starting with 16 moles. We know we have 16 moles of water being produced. Okay? So we know we have 16 moles of water being produced. That's step 1. We know that's given from our problem. Step 2, determine what we're converting to. We're starting with moles, and we want to know how many particles are produced. So that means we're going to convert to our particles. Okay? So that means we want particles on top and moles on the bottom. Okay? Anytime you're doing conversions, whatever unit you want to end with is going to be the unit that goes on top for these single conversions. Okay, so because I want to end with particles, particles needs to be in my numerator. Okay, because I want to get rid of my moles will have to be in my denominator because this is a fraction problem, right? So we want our moles to eliminate. So if we want to get rid of our moles, I need to have my moles in my top and a mole in my bottom so that I can eliminate these, so I can reduce them. Okay, this is just math problems. You've probably done these. You've definitely done these since you're in chemistry. You've done these in a math class along the way, but it's the same concept just with chemistry units instead of the math units you're used to. Okay? So the moles will eliminate and the particles will be left. Next we have to, so that's what we did. We set up the units so that they cancel property. So we've done 1, 2, and 3. Now 4 is to add the numbers based on the conversion factor. For these problems, your conversion factor will be 1 mole is equal to 6.022 times 10 to the 23rd particles. Okay? The 1 will always go with the mole, and the 6.022 times 10 to the 23rd will always go with the particles. It doesn't matter if it's in the numerator or the denominator. 1 always goes with the mole. 6.022 times 10 to the 23rd always goes with the particles. Okay? So our 1 always goes with the mole, and our 6.022 times 10 to the 23rd goes with the particles. Okay? That is the setup of the problem. Now that you've got the problem set up, you can solve. Okay, this is again a fraction problem. The easiest thing to do is to multiply across the top, multiply across the bottom, and then divide. Okay, so if we take a look here, I'm gonna go ahead and just do this on a calculator. But if we type in 16 times 6.022 times 10 to the 23rd, and then that will give us our answer because there's nothing here and there's only 1 on the bottom, so everything would be divided by 1. So let me go ahead and exit out of here and find a calculator really quick. So we've got 16 moles, so we'll do 16, and this is the Desmos scientific calculator. I'll link it in your lessons. But 16 times, and then I'm going to do 6.022 times 10 to the 23rd, and then we need our closing, and then we'll press this little blue button here, and there is your answer. So 16 times 6.022 times 10 to the 23rd will give us 9.6352 times 10 to the 24th. This is going to be your answer. Okay, so that answer to that question is 9.6352 times 10 to the 24th. Okay, so if we go back and see this again, remember, you're just multiplying across the top. You would multiply across the bottom and then divide if you needed to, but because these are both 1 times 1 is 1, and then if you divide by 1, you're just given, whatever answer is on top. So here we just had to do 16 times 6.022 times 10 to the 23rd. Okay. I know right now this might seem a little overwhelming,